Okay, in this video, I'm going to give you one more example of doing an empirical formula. We're going to start off with percentages, and we're also going to determine what the molecular formula is given the molecular mass or molar mass of the compound. So let's get started. The first thing that we're going to do is we're going to convert these percentages into grams, and then we're going to convert them to moles. If we assume that we have 100 grams of each element, that means that those percentages are simply grams, and we find those masses for each element off the periodic table. 1 mole of carbon is going to have a mass of 12.01 grams. 1 mole of hydrogen is going to have a mass of 1.01 grams, and 1 mole of chlorine is going to have a mass of 35.45 grams. When we go to calculate these out, I would tell you to carry them out at least as far as the number of significant digits in the original value, or a little bit further. If we convert, when we calculate this into moles, we're going to get 3.636 moles of carbon. We're going to get 4.713 moles of hydrogen, and we get 1.454 moles of chlorine. I would encourage you to do these calculations on your own as well on paper, so that you just have a feel for how it's done. Now, our first step, once we have gotten our moles of each element, our next step then is to take the smallest number of moles, in this case the 1.454, and divide all of them by that value. Now this is going to give us a 1 to something ratio for our subscripts. But we're also going to make sure that we keep in mind that we have the possibility of some fractions: 0.25, 0.33, 0.5, 0.66, and 0.75. You want to watch for those values. If you have, when you divide by the smallest, answers close to those decimal values, you keep them. And then we will find a numerical value to multiply through to get rid of those fractions. So if we divide by that 1.454, that's going to give us a value of 2.5 moles of carbon, a value of 3.24 moles of hydrogen, and 1 mole of chlorine. So what this is our simplest ratio based on the moles given these percentages up to this point. Now, if we were to stop here, these would be our subscripts, but we cannot have subscripts that are not whole numbers. So we need to find a value to multiply through these by to get rid of those fractions. Now, if we multiplied this value by 2, that would give us 5, and that would get rid of that fraction. We could multiply this by 4, and that would get rid of this fraction. It would also get rid of the fraction here. And so we're going to take all of these values and multiply them by 4. So that gives me 4 chlorines. That's going to give me, times 4. 4 chlorines. That's going to give me, now when I did this, I just simply used 3.25 because it's close enough to that value. That's going to give me 13 hydrogens, and when I multiply that by 4, that's going to give me 10 carbons. So my empirical formula for this compound is going to be based on those whole number values that we got for our ratio. So my empirical formula, C5 or C10 H13 O Cl4. Now This is the empirical formula. It's the simplest whole number ratio. We want to know what the molecular formula is. And the molecular formula is going to be found by comparing the mass of this whole formula to the mass of the actual compound's formula. So we're going to set up a proportionality and say we have 825. That's the mass of the actual compound. The mass of C10H3Cl4 is going to be 275 approximately. I'm rounding to the whole. And when we divide that out, we are going to get a value of 3. Now what that means then is that our empirical formula has been reduced by a factor of 3. So this empirical formula is 3 times less than what the actual formula is. So we simply take all of these values and multiply them by 3. So that our formula for the compound, our molecular formula, is C30H39Cl12. And that would be our molecular formula.